Yes, that's right. So the idea is that they should be able to modify their own customers and send them back up. So at this point, if I create a customer on branch A, or if I modify a customer on branch A, it will go up. It will go back up to the head. What we need to do is we're going to modify the same customer on both sides, and we want to see how that's handled. I'll show you the code first. In CC Replicator here, we have an event called onResolveConflict. This is fired every time the system detects a conflict. So what happens is when Copycat when you call replicate, it opens database connections and it loads the RPL log table on both sides. It reads them up using the node names that you configured. And it loads all this into memory, and as it loads, it merges the two logs and detects any conflicts if there are any. And so this is launched, this event is fired as soon as a conflict is detected. So it's before any replication takes place. It's while it's loading the log of changes to replicate. It passes you a tconflict record, which is just a simple record that holds the information about the conflict. So here I just add a little line in my memo that says if we detected a conflict. I'll show you what we have in here. So we have node 1, node 2, those are the names of the nodes that are trying to replicate together and have a conflict. First operation date, last operation date, that's because when I read the RPL table, RPL log table, I do an aggregation, because depending on how frequently you replicate, there might very well be several, the same record might have changed several times, and there's no point replicating it several times, so I do an aggregation. So this means the first operation date means the first timestamp at which the record changed and the last timestamp at which it changed. 1 and 2 for each node, so you can compare. And you have the number of changes. And you have chosen nodes, so that means if you implement the onResolveConflict event and you want to resolve the conflict automatically, if you can, then you do as I did here. You set chosen node equals the name of the node to which you want to give priority. So that means if we have a conflict between head and branch A, for example, then what I've written here will keep the changes from branch A and overwrite the changes from the head office. Okay? That's all there is to it. And then you'll probably want more information. For example, you might want to get the data on both sides. That's easy to do because if we write cc replicator a dot log, so log that holds the that's when we read the RPL log from the databases stored in memory in this object, this log object. So here I have all the contents of my RPL log table, and in particular I have keys. And so here I have an array of keys. Okay, so this means I can retrieve the primary keys, and once I've got the primary keys, I can make a query onto my onto node 1, make a query on node 2, and get any information I want. Okay. So here, of course, I've taken a simpler solution. We just arbitrarily say if there's a change to a customer, keep the changes from branch A, just to show you. But of course, in reality, you probably want something a bit more sophisticated. Okay, that's all there is to it for handling conflicts. And I'll show you how it works.
Prove that it works.
Yeah, have to prove it. Okay, so here, for example, between branch A and the head office, we've got this customer. We'll change it on both sides. So we'll say changed by head office. Yeah, I'll maximize so you can see what I'm doing. And, okay. The event, if I look at the conflict, okay, we've got between node 1 is head, branch A, we've got the operation dates, we've got everything, all the information we want. Okay, and we set conflict chosen node equals branch A. replicated row from customer tables, from table customer. If I go back over here, there it is. Okay, so so that's all. That's all I wanted to show. Except here, I just want to show you the events I've used. It's very simple, but here I've got an event that fires when the log is empty. Okay, so if it loads the logs and there's nothing there, it just fires this event, so you can know what's going on. Yeah. So yeah. If there's an exception, okay. If there's a replication error, so the difference is that if there's a this one fires if there's a row that is trying to replicate and it can't replicate it. If there's an exception while replicating a record, a foreign key violation, anything, then this event is fired. And here I wrote can continue, so that simply means the record that we were trying to replicate, we keep it in RPL log, we try it again next time, but we continue with the other records. Okay.
This happens sometimes when you have foreign key dependencies. Okay, sorry. For example, if you're replicating a list of invoices, and it has a customer number field, and it's a new customer, so it tries to first replicate the invoices, but it can't insert them because the customer doesn't exist yet. So what happens is it goes through all the invoices it can't insert, so it leaves them in the RPL log, and then it gets to the end and it inserts all the customers, and then on the next replicate, then it can insert sometimes you can handle it by changing the order of replication, but sometimes it's they have dependencies, mutual dependencies, and then the only way is to go do a second work.
Yes, so in other words, it's not necessarily a problem. It can be normal. We have a system of where you can set the priority of the table so that changes from this table always go before this one. But even that is a little bit coarse because then if you delete, it's the other way around. So we just, when it's like that, we just leave it in RPL log and try it again next time. If it stays there for a long time, there's a problem. But if it's just a line that doesn't go, it'll probably go 5 minutes later. So there's nothing really to worry about. Anyway. So that's why there's two different exception events. Here, on the other hand, it's an exception while reading the log, a general exception that we can't recover from. So, yeah, can't connect to database, whatever. Okay. And row replicated. Well, here we simply have the row that's replicated, and here you see I'm retrieving from the CC replicated component. I'm retrieving the table name. I could retrieve other information. I can retrieve the primary keys. I can retrieve anything I want from that. Questions? And yeah, probably time for questions, if there are any.
I have some.
Okay.
Is there a way to synchronize multiple same-level servers? To do two-way synchronization between three servers, for example, or I just set up three synchronization pairs.
Use three synchronization pairs. It amounts to the same thing because if you have A, B, and C, A replicates back and forth with B, B back and forth with C, and C back and forth with A. And anything from any one of them will go in a circle. Yeah.
Then next problem. And this one comes from my practice. Your approach requires that both databases are visible from one application. What if I have two servers each with its own database and I want to synchronize them? Can I tunnel somehow the replication requests and responses from one server to another?
You mean so there's no
servers that are visible to the world only through some SOAP or REST interface.
Oh, yes.
Yeah, I see.
The server runs internally embedded database. So I cannot access the other database directly from either of those servers.
Well, it depends. Well,
we've implemented something like this with using XML-RPC web services. So we've built basically it's a Java proxy for Copycat, and so this will run on your application server, and it can access the database, but you can have obviously access the database from outside, and so you're going to and we have an XML-RPC transport component within in Copycat that you could just plug in as instead of the direct database connection. So at the moment, until we get more customers, we haven't had the time and resources to implement other transport layers. But the system is built to allow different types of transport layers. Just show the couple components, Ro. Okay, well, it doesn't matter. But yeah.
Actually, I would only need a transport level hook that I can.
Yes, then afterwards you can. Exactly.
Yeah.
Just
Yes.
Yes, you can tunnel like in one way or another. You have to be able to access both databases at the same time, of course. Otherwise, you can't. You wouldn't be able to handle conflicts. But yes.
Transport doesn't have to be direct.
No, and yes, I have a class called. I got a bunch of classes that handle the transport layer abstraction. And as Raphael said, the way it works is that it plugs in instead of these components we have here. You just get rid of the UIB, okay, and you could. I mean, we would like to one day support other protocols, but you could also implement your own protocol. It's a bit of work, but you just derive a few classes, and yeah.
Okay, and the third one, which I don't know if it really is a problem, just popped in my mind while I was listening to you. If I have a bunch of updates that happen inside one transaction, they will not be executed as a transaction on the replicated database. Is that true?
Okay, so
There will be disconnected updates on the.
the transaction handling is it can be any way you want, because here in the replicator by default it doesn't. In fact, by default it's on none. So that means that by default it's up to you to commit at any time you want. You can commit every time you replicate a row. That's what I recommend. But it depends. There are situations where maybe you want to, I don't know, commit every 50 rows, or. But yes, if you have a, in the situation you're talking. Well, no. But I would say. I would say it's. I wouldn't think it's a problem because if in any case if you committed the transaction, then it's committed. So there's no reason to bunch up those updates anymore. I would say.
Okay, thanks. And I must say it looks like a very clean solution to a very messy problem. So I like it.
Thank you.
The configuration process on the table discover automatically primary key.
Yes.
Even if it is made of several fields.
Yes. Yeah, that's detected at runtime, which means that even if that changed, you change the primary key. It's while it replicates that it queries the database and figures out what the primary keys are. Obviously, that would only work if you have nothing left in RPR log. You have to clear it. Because yeah.
Which may be worth mentioning. The system doesn't replicate updates.
Not yet. I would love to do it one day, but for mirroring, but that doesn't work yet.
Okay.
Any more questions?
Okay. Well.
Okay.
Thank you very much.
Thank you very much.
€50 for a developer seat for the license, and it includes source code. We didn't.
The royalties. So.
Yeah, we did We did used to have non-source code and source code, and we got rid of this, simplified it. It's just 230. You want the source code anyway, okay? Yeah, we don't want to sell it without. We also have 200 per developer seat, and then we have also options for when you're setting up your project. You can buy support from us, and we'll accompany you in setting it up, making the right choices and everything like that. This was also an issue at one point. We also have a standalone application called Copycat, which is basically it's just an application which you can with a wizard, and you can set it up, point to 2 databases, click, and it installs everything and runs in the background as a service. So this is for doing any kind of replication, and we even have another one that does mirroring called Live Mirror that basically doesn't ask any questions, just says base A, base B, go, and it does and it's powered by obviously our components. That's it. Scroll down a bit. Yeah, we've got different options for the support and stuff like that.